This is Software Meets Business, a podcast sponsored by Head Channel.
Today, I've got Julian Browne with me, and Julian and I have to be disclosed that we've known each other quite a long time. Julian's now the CTO at Modu Digital, and today we're going to be talking about something that's pretty much impacting the whole world. So shall I let you say, by the way, we're both wearing green, which is very calming, I think, for a topic that could be quite frustrating. So what is the topic, Julian? I'll let you mention that.
Well, I guess we're going to talk about artificial intelligence.
What?
And which of those words actually apply to the technology referred to as AI?
Do we need to be grumpy and slightly on a high horse about what artificial intelligence means and where the word came from? And is it really? I suppose that is part of the thrust, maybe. It
is. I mean, well, I suppose for the historical record, because it's not opinion, the term artificial intelligence comes from John McCarthy way back in the 60s. Was the 60s, wasn't it? And he was trying to put together. I think it was for. It was for the Dartmouth famous summer get together. The Dartmouth get together, and he wanted to bring together people with slightly different backgrounds and perspectives on various studies of technology that was attempting to resemble the human brain.
Yeah.
And in order to kind of come up with a term that would bring people together, but also, and I said this in this that thing I stuck on LinkedIn the other day, he was also doing a little bit of marketing because he was saying, let's all get together, let's discuss some stuff, but also let's be a bit ambitious. Let's not just talk about where we are. Let's talk about how we could make this thing fly.
And so the term came to, it kind of hit the zeitgeist, was it? Would you say? Or
honestly, I don't know if it hit the zeitgeist in the 1960s. It probably did, because the 60s was a bit of an era of, the space race and everything else. I think technology was on a bit of a pedestal. So I'm
Robbie
sure
the robot.
I'm sure it did capture the imagination. But interestingly, and I'm doing this. I don't have any screen in front of me. I haven't got ChatGPT telling me this. But
have you got Cluey switched on?
The roots of AI, the roots of most of what we could consider to be the sort of core bits, the neural network part of artificial intelligence, actually goes back to 1947. I know this because I did a talk on it recently, to a paper by two guys called McCulloch and Pitts, who had, and I can't remember the name of the paper, but it's got one of those sort of very classically 1940s academic paper titles. It's about how nerve cells, or the operation of nerve cells, appear to work a bit like mathematics.
Yeah.
And it's called something like the inherent calculus in arising from nerve cells. Anyway, whatever. It's got one of those.
We'll look that up and stick it in the description.
Yes. It's like a lot of papers from that time. It's strangely readable, and all they were basically saying is a neuron takes some inputs, does some sort of processing. Mm-hmm. And you can sort of, they say this, but you can infer this, that the processing determines the importance and relevance of those inputs. I can hear the roar of a beast that's going to eat me, goes into my ear, gets processed by some neurons, and it produces an output, and the output is run.
Yeah.
And then I think it was 7. So I need to remember the number 7. So I think it was 47. And then there was like 7 years later when Frank Rosenblatt wrote a very famous paper in the world of machine learning, which was the creation of the perceptron.
Yes.
And the perceptron, I think this is true, was the first mathematically sort of usable model of a neuron, which worked in exactly the way I just said, as in it takes some inputs, processes them, and produces an output. And the perceptron, as described in that paper, is the first sort of incarnation of a neuron, as in the neurons that we talk about in the neural network today. There are some subtle differences. So I believe the first ever perceptron, should have read this before coming on a podcast, shouldn't I? And I think this is true. The original perceptron was, well, there was one important difference between the perceptrons and neurons today, which is a perceptron took some inputs, processed it, and produced a very binary output, like a yes or a no.
Right.
Whereas neurons now, they'll use a function to produce a probabilistic and typically a number between 0 and 1, which is this is how much I think this thing means something based on what I've been told.
Yeah. Which brings us on to what, so weirdly, not much has changed, because where we are now.
Okay, so not much has changed, but also a lot has changed. At the granular level, you could say not a huge amount has changed. If you understand very basic algebra, mathematics, I mean linear algebra, but if you start with just basic mathematics, you can understand a perceptron. If you start joining perceptrons together, let's make them neurons. If you start joining neurons together, then as a whole, they start to behave in a very algebraic way, as in a perceptron on its own, you could think of as being a mathematical entity. Suddenly it becomes all about linear algebra. That then spawns a whole series of problems that need to be solved. And that's all quite new stuff. So you've probably heard of the AI winter, or winters. There have been more than one. So typically what happened is, I also missed out Turing's paper, because 7 years after McCulloch and Pitts, Turing wrote the imitation game paper, which is the Can Machines Think, sort of bringing it all together into you can now tie the neuron in a human brain to a perceptron, a mathematical entity that tries to emulate it, to Turing saying, what if we got loads of these and very expensive hardware? NVIDIA didn't exist then, but
no.
And that he sort of postulated, and that's where the whole Turing test thing comes from. Some very basic things haven't changed a lot, but I think that's doing a bit of a disservice to the thousands of incredible machine language researchers and machine intelligence researchers and data scientists and whatnot over the last sort of 30 years, because a lot has changed at the macro level.
Yeah.
I don't think in their wildest dreams they ever would have conceived. I mean, maybe in a fantasy, but I don't think they'd have been blown away by ChatGPT.
Yeah.
Yeah, I think.
Which I suppose brings us to that bit. So I remember, obviously, a neural net, as in a bunch of emulated neurons being able to recognize things. And so, used to have, is this a traffic light? Yes or no? You could pass in an image of a traffic light, and then it would tell you with some confidence or some, or a number which represented confidence, how much it thought that might be a traffic light, essentially. And I'm saying thought. I mean, we'll get onto that.
Yeah. So if you take the neuron, and as in the computer science variant, not the human brain, the thing you're talking about, a convolutional neural network, is able to, I mean, simplistically, what's happening is you're sort of taking, in your example, you're taking almost like the template of a traffic light, and you're sliding it around on the image that it's looking at until you find something that actually matches.
Mm-hmm.
And then what it will do as the template slides over the neurons that can now spot a traffic light, because the traffic light could be anywhere in the image, as those two things kind of come together, suddenly that collection of neurons will go, oh, this is 0.8573, the probability of being a traffic light.
Yeah. And so
that's slightly different than the kind of neural nets that process language. I mean, but again, at the root level, what's happening inside, all very similar.
Yeah, at the root level. So that was all the rage back. I think in the last AI winter, and then something happened around generative.
Yeah. So I don't remember the winters off the top of my head. I think there was one in the early 21st century, so around about 20 years ago. I think there was one in the 90s. But basically what happened, and I think this is significant, and obviously this is where we need to be a bit careful, because just because something has happened in the past does not mean it would definitely keep on happening. But also, when something has happened in the past and it was caused by certain factors, if you see those factors appearing again, it would be a bit of a mistake not to at least speculate on whether we're about to go into another AI winter. Even though that seems insane in 2025 with all the hype and everything in the news, but in the previous AI winters, what happened was some incredible breakthroughs were made, and people who were not necessarily in the field saw those breakthroughs and went, oh my God, this is going to change the world. Let's put loads of money and PR or whatever behind it. And then time went past, and this doesn't invalidate the work. This is more of a reflection on what markets do and investors and just human emotions. Is either progress wasn't fast enough or expectations weren't met, and then this kind of then the opposite effect happened, which created the winter, which is suddenly everything about that technology became like a dirty word.
Yeah.
And then an AI winter came, and the AI winter is when you leave university with your degree in data science, and no one's hiring to develop these incredible models. And that is strange. I mean, it's not strange. It's very easily understandable. It's very logical. But it is weird when you're talking about a piece of technology, because technology isn't magic. No piece of technology is magic. It's every bit of technology, regardless. I'm not talking about AI. I'm talking about everything.
Yeah.
It does what it does, and it has a certain limit. And sometimes there's limits over time with advances in the technology. That we can push the limits, but to sort of take these models and then take them to a point where the investors are going, oh, I'm really disappointed. I'm now not going to invest in machine learning for the next 5 years because it's all rubbish, is a bit of an overreaction the opposite way. It was like there was an overreaction when they saw this thing that could spot a traffic light. And then when they realized it couldn't power a self-driving car in 2005, all the money disappeared.
Yeah.
But what happens quietly is, of course, these jobs don't disappear entirely, is that is some research is done, and then occasionally people will find a way through and make a breakthrough. What was the generative AI kind of resurgence? I mean, or surgence? I mean, I think the commonly accepted sort of story is that 15 to 20 years ago, the general view was that if you took a model, and this applies to most big statistical models, and you made it bigger and bigger and bigger and bigger, and you fed it more data, and you tweaked it and tweaked it and tweaked it, eventually it would start to collapse in on itself. Eventually, because these things are so horrendously, like they're so massive, our brains cannot even like comprehend them. But these things just become so big, they almost like develop their own, like almost like a black hole. The density of the thing just makes it fold in on itself. And so there was a received view, let's say, that there was not much point in just investing loads of money, because the bigger it got, the more eventually it would just collapse.
Yeah.
And then, I mean, two papers that I was flicking through recently, the lottery hypothesis and what's it called? Is it called Many Experts? What's it called? The other paper. We'll put a link in. I can't remember the exact name of it now. Mm-hmm. But particularly the lottery hypothesis. I think I'm getting this right. Yes, I'm pretty sure that's the foundation of the lottery. I may be about to make a connection, a mistake here, but I'm pretty sure that this is right. But yes, so the view was larger models would collapse in on themselves. Mm-hmm. But then this whole sort of area of research proved that if you took a really, really big model, one that would be about to collapse in on itself, trained it, and then deleted the parts of the model that are not firing in the useful, so you feed it in all the useful inputs and measure all the useful outputs, and some parts of the model are not going to be doing much. They're just things that are sort of on the periphery. Mm-hmm. If you remove those, you end up with a small model that is awesome. And now you can start to grow it. And suddenly things that were not, this is exactly what I was talking about before, about pushing the limits, is a limit that we thought existed for the size of a model seemed to go away.
Yeah.
I believe that's the lottery hypothesis paper, but I've read so many papers recently that they're all a bit jumbled up in my head.
Yeah, the hypothesis, lottery ticket hypothesis, is there's a small sparse sub-network, which is the winning ticket.
Yeah.
Can be trained in isolation to achieve the same or better performance than the original larger network.
Yes.
So this is what's started to happen.
Yeah. So I wouldn't. I mean, I should say I'm not an AI historian. This is just stuff I've sort of picked up as I'm doing the day job. But yes, so there was an AI winter because everything was very disappointing, and then some limits were removed, and now we're in the next wave.
But there's been a flip, hasn't there, between the models being able to recognize things to the models being able to generate?
Yeah, although I guess, was that a leap? I mean,
well, I kind of understood it that I read a really good book, and I'm trying to remember the name now, and I'll stick that in the description of all. You look like a thing, and I love you. Yeah, by Janelle Shane. I probably get both of those pronunciations wrong. And she wrote a really good book about training models to generate poems and things of that nature, which was kind of around that same time. But then my understanding was that they took all of the Amazon reviews they could possibly get and tried to make the model as big as possible. And then they really started to see some better results.
Right.
That's what I understood it to be.
Yeah. I don't know if yeah, that's an interesting point. Is the current wave?
But this is in the generative space, right?
Yeah, I mean, I think we could probably say yes. I mean, you'd need both of those two things. I guess I've never really thought that whenever I've read about the advent of generation, it's not. I mean, God, I'm not saying I could have done it by any stretch, but it never really felt to me like an absolutely like a massive breakthrough, in the same way that having a model that was 1,000 times bigger than the ones that you thought you could have was a huge breakthrough.
Yeah.
Because if you took something basic like chatbot technology, the chatbots have been around they got to have been around for at least 20 years. I don't remember the first chatbots, probably even before then, actually. I mean,
going back to Eliza.
Well, that was yonks ago, wasn't it? But there were expert systems in the 1990s, and there were chatbot-like interfaces that were based on expert systems. They were awful. You couldn't really have a fluent chat with them, but you could ask them a question. I worked on a programming language called Advisor in '94, which was an expert system generator, and it allowed you to configure a complicated server farm. This is before cloud, and I mean, this is in a data center.
Yeah.
You could tell it your requirements, and it would work backwards and sort of build you a server. It was not a fluent interface, but it wasn't kind of programmatic. You could type things in fairly general text, and you could get answers. Mm-hmm. But that is night and day compared to talking to Claude or something, where the fluency is like talking to a human being.
So when you were younger, I mean, I certainly, as a kid, I was always fascinated about language, and I realized, as I think pretty much everyone does who sits around thinking about this stuff, that some words are more likely to follow other words, and those words are more likely to be following other words. And so when I was a kid, I wrote on my Spectrum. So hold on, I wrote a program which had a bunch of words in it, and then other words that were likely to follow that word. And then it would go and look for the next word, and then find the next words that were likely to follow that word. And essentially, used to output a whole bunch of text, which sort of made sense, but didn't really. So,
so that's like a Markov chain.
Yes.
And so Markov chains are like 12. It's very early 20th century, but not right at the beginning. So I've got a presentation that I do to clients when they say things like, we're thinking about doing something with AI. Mm-hmm. We sort of feel that we should, because everyone's saying that we should definitely dip our toe in the water. But what we don't want to do is go, oh, AI is magic. Let's put all of our investment into AI, find out that it's not going to do what we think. But if we don't put anything into AI, then our entire business could be at risk, because some 16-year-old kid could be recreating our business using Cursor right now, and we're dead.
Yeah.
And so the point of this presentation is to get people to a level of sort of intuitive understanding of how some of these models work, just so that they can make their own good decisions. Like, I'm not going to say to anybody what you should or shouldn't do. That's because it's your business. You need to make your own good choices. But I can help you with some information that can at least sort of bring you to a level where you can make those decisions. And I talk about Markov chains in that presentation. And in my example, I take some fairy tales, so Snow White, Little Red Riding Hood, etc. They nearly all begin with once upon a time. If you take the word once, it's followed by upon. Mm-hmm. But throughout the entire fairy tale, the word once appears in many places, and it's not always followed by upon. But if you took a fairy tale, in fact, if you took just the first couple of paragraphs of a fairy tale and chopped it up and had word and all the words that could follow that word in a list, and then you added some statistical weighting to those things. So once upon is a very, very common couplet, whereas once, and once again probably is, but once after, maybe, I don't know.
Yeah,
probably
once therefore.
Yep. Once tractor. You'd have other couplets that are less likely. And if you then wrote a piece of software to pick a random word and then follow the next word and then take that word and go and look at where it's got its successors, pick a successor, and so on and so on. I actually wrote a little Markov chain generator using the Donald Trump speeches, because the text of a lot of his speeches is available online. You can also do things like take the works of Shakespeare, because there's that famous machine learning. It's like a distilled all the works of Shakespeare in a massive text file. And you can build a Markov chain from a piece of text like that, and then you can walk the chain to produce a sentence. Sometimes you'll get a sentence that's quite long and actually makes some sense. And then other times it'll just completely turn into garbage. But each word in that output will still be valid as the twosome. Each word is still valid. It's just as a sentence, it doesn't make any sense.
Yeah.
And the reason, and even though Markov chains have got absolutely nothing to do with machine learning or AI or ChatGPT, they're like the fish coming out of the water to breathe air for the first time, in that you can, if you understand what a Markov chain does, and you can understand a Markov chain because it's really simple, but if you then sort of think about a Markov chain, you can start to get a bit of a grasp on what's happening inside a large language model. When you walk a Markov chain and you get gobbledygook, that's kind of a hallucination. Those words are words that follow words. Individually, they're all correct, but overall, it doesn't make any sense.
No.
Why? Because when you built the Markov chain, each word was only looking at the next word. So basically, each word is based on its previous word. And so you've got the beginnings of the concept of attention, because you're paying attention in the transformer architecture sense only to the last word that was said. So based on the last word, I'm going to go and pick the next word. But you can build a Markov chain that actually looks back 2 words or 3 words or 4 words. They start to get pretty horrendously complex, but you can do that. Obviously, then you can think of it like a key and a value. Each key in a Markov chain is 1 word and then the subsequent words, but you can have 2 words as the key or 3 words or whatever. If you do that, you can actually start to get sentences that do make a lot more sense. But your variance in your, so something close to temperature, I suppose, but your variance in your output is going to be quite boring. So something as simple as a Markov chain already starts to tell you a lot about how ChatGPT works.
Yeah.
In the example where you take a fairy tale, which has got a few thousand words in it, and when you're only looking at basically a single dimension, it's pointing it's a clue. It's pointing in the right direction. But then you start so take those numbers and then take the numbers of a modern LLM, where you've got literally billions of words and 16,000 dimensions, and so on and so on, and attention spans of, instead of 1 word, it's
whatever the context window is, right?
Yeah, but to tens of thousands. You can start to see that there is a sort of a line of sight, if you like. I mean, it's dangerous to start extrapolating too much, but the very basic properties And that's why people who dismiss LLMs call them predictive text, because for a long time predictive text was based on technology, either very specifically Markov chains or something very much like it.
Yeah,
and that's why you remember in the old Nokias, if you typed the word love, it would nearly always replace you by pressing the right keys. It would replace it with the word home.
Right.
Because home is a much more common word to type than love, but it's based on the same numbers on the keypad. So when it's doing that predictive, is that called T9? I think it was. Yeah, I think it was.
I don't remember.
Anyway, whatever it was, and it's not true to say that an LLM is. Well, is it true to say it's just the smarter predictive text? I mean, I feel uncomfortable saying that because it's not. There's a lot more to it.
It's not. Yeah, it's not a Markov chain. It's much more complicated than that because it is multi-dimensional. I don't know how to say that in a bigger way, but
yes,
it's the dimensions, isn't it, that really give it. And then each word is connected to every other possible word, but with a weight. Of it, although I suppose some words just would never follow other words; they just would never do that. But
no, and then they won't appear in your Markov chain, so therefore they'll never. So if it was never in the input data, it will never be in the output data.
And also, I think the other thing is obviously they're not really using words; they're using tokens, which are shorter.
Yeah. So. Yeah, and this is that's an interesting area where it sort of it's an area where the line of sight from Markov chains to LLMs sort of breaks down a bit because this is where there's a lot more to it than just you didn't just make a bigger Markov chain and then suddenly.
You could write the next Donald Trump. Well, actually, you might be able to, but anyway, that's a different, probably a different episode. So, where does this bring us all to, though? Because we're all being told that we're all going to lose our jobs because AI is just going to be able to do everything. And when you go and use AI, it's very convincing.
Yeah. So, I mean, I think the reason my perspective on it, and I thought this right at the very beginning, because about 20 years ago, I can't remember if I ever told you this. I probably did because I would tell anybody that would sit down long enough to like me to bore them to death with it. I had this idea, and it was born out of a very personal need for a solution to a problem, which is in I think like 2003-ish, there was a massive downturn in the tech hiring world. It went from you could leave a job on a Friday, have another job on a Monday, to all of a sudden it was really difficult to get a job. That's also interestingly significant to the current world, because I've been in the world of tech for so long that I've seen these peaks and troughs, and so the troughs don't bother me as much as they used to because we're always not very far away from another peak. It's a weird thing. You just have to go with it. But in 2003, I wasn't particularly keen on going with it because I stupidly decided to take a load of time off work and then decided to go back into the market exactly when it was dead. And I felt very viscerally the limitations of hiring systems used by recruitment consultants, because any job that came up, so JobServe was probably the main place to go and get a job those days. A job would come up on JobServe, and if you hadn't applied within the first couple of hours, you were application number 250, which is probably something people recognize on LinkedIn now. You see a job that pops up on LinkedIn, you'll often see over 100 applicants written underneath it. That's a sign of a market where there's not many jobs and a lot of people who are sort of thinking about moving. And this was happening in 2003 or so. And And I thought, this is mad. I'm obviously not perfect for every job, but I've got a certain set of skills, a certain set of experiences, a certain kind of personality type, and I'm sort of representing that to the market via this ludicrously overly simplistic thing called a CV or resume. And then I'm trying to match that, or I'm trying to match me via the resume to someone else who's doing exactly the sort of mirror effect of they've got a job and they want somebody with a personality type, a certain set of skills and experience. And they're doing that via the ludicrously crude piece of paper called the job description.
Mm-hmm.
And in the middle, you've got the poor recruiter who's getting CVs and job descriptions and trying to slam them together. And I thought, surely, semantically, surely in a kind of where if we got, there's a lot of data here, a lot of words that follow words, there must be a way to take not my CV, but something, some kind of something I could write and something an employer could write and go, oh, these things overlap. Like in the Venn diagram of all the, there's a me and then there's jobs, and find all the ones that overlap.
Yeah.
And so I started working on different ways to solve that problem. Some of them deterministic, so some of them just code, and some of them into language processing. And I built various versions of this software over the years. But then, or maybe a few years later, thinking about it, it would have been probably maybe 5 years later, word embeddings became a thing. I don't know if you ever really sort of came across those, but essentially,
yeah.
I mean, it can get very complicated, but you made a reference about a sort of multi-dimensional like array. Word embeddings take some input text, and essentially they build a model which is this multi-dimensional array where words, there's a famous example that if you take the word king and imagine that there's some sort of origin point between the kind of like 0 and the word king, because it's in an array, right? So it's a bit like a sort of a graphy kind of structure. Take the word king, and there's a gap, there's a space between the word king and 0. Mm-hmm. And if you and then there's a space between the word crown and 0. If you take that distance, the sort of the vector of crown, and subtract it from the vector of king, you'll end up roughly where the word man exists. If you add, am I going to do this right? I'm about to go and mess this up. If you take the word woman, I may have got this slightly. Actually, the paper has got various different. I can fudge this. The paper that the very first paper that talked about this said if you take the word woman and add crown, you'll end up with queen. Mm-hmm. So what I was trying to do actually was a slightly different thing, which is if I could get a bag of words from a document or multiple documents, would I be able to describe a project manager? Because I can describe a Java developer in there's certain words that describe a Java developer, because there'll be all the different libraries and approaches that a Java developer 20 years ago would have been into, probably EJBs or something. But a project manager is quite a difficult one. Like a project manager has behaviors and some Prince 2 and things like that, but there's like a lot of words about time and budget and control and risk management and all those other things. And I did some experiments with word embeddings, and they're multi-dimensional, but there are some really good online some online sort of interactive examples where they basically sort of flatten these things to 3 dimensions. So you can actually fly around a word space and see where all the words from the input documents end up. And the words that have similar meanings tend to cluster together. And then you can navigate this space by taking concepts and subtracting them or adding them to one concept, and you can navigate through the space. And I think because I and I was never an expert in word embeddings, but I did make some substantial progress in trying to define the woolliness of a project manager and the woolliness of a project manager job description. So tell me about you as a human without the CV. Tell me about you. I'm going to talk about this job over here. Do these things start to come together? Word embeddings could do that. Nothing like a modern LLM can do, because one thing that LLMs do, which is incredible, is they can deal with a whole long tail of. So I can describe things in lots of different fuzzy ways, and whereas in a deterministic world, I'd have to code for those different cases. It's one of the massive powers of an LLM. But I think because I went through all that learning experience with word embeddings, that I could sort of visualize these models, partly because I'd actually played with I built some models myself, and I played with them and had a reasonable grasp of them. And then when I first ever used ChatGPT, I said this the other day, I like most people, thought it was probably a very clever trick.
Right.
It was that amazing. I found it hard to think anything other than than there was some sort of consciousness or. And honestly, when I started to read things like the Transformer paper and the data about the size of these models, I started to think two things. One was, well, yes, obviously these models can do what they do because they are so enormous. Like the input. The number of words that these things have processed is more than the number of human beings that have ever lived by quite some way. And I don't think we can even handle numbers like that in our head easily.
No.
So obviously, again, there's not a direct line of sight between word embeddings and LLMs, but it's at least a bit closer than a Markov chain. You've sort of like, if you're trying to plot this sort of evolutionary tree, they do all exist in the timeline, but one didn't necessarily give direct rise to the other. But the properties and the way of thinking about how they work, largely speaking, isn't that much different. Certainly not if you abstract it away from some of the implementation details. So what I started to think about ChatGPT was, first of all, well, yes, no wonder it does this, because it's absolutely massive. And word embeddings could do some pretty interesting stuff. Like Markov chains could do some interesting stuff. And then the second thing I thought is this question of consciousness or intelligence or whatever, if an LLM can absorb all the words and all the relationships on the entire internet plus any other corpuses of text that it can get its hands on, is that not in a way what our brains do anyway? I mean, and I don't know how the human brain models this stuff, but it wouldn't, if someone said, yes, that's exactly what a human brain does. It's got this sort of multi-dimensional, sort of vector-driven data structure, albeit inside cells. I don't think I'd be particularly surprised. So it then gives rise to another question, which is, well, what is it when you're having a fluent conversation? What are you having a fluent conversation with? Because it's on the one hand, yes, it's just a bunch of words that are connected to other words. But if that was a way of slurping out your brain and putting it into a data structure, as in it's the encoding of something that's a bit like intelligence or a bit like consciousness, then is that a possibility? They were the sort of two thoughts I had at the same time, which is it's not magic. It's definitely not magic, because I've worked fairly closely with systems that are not magic, and this is just a much bigger version of those things. So
Yeah.
I'm not awed by it. Well, I was awed by it. I'm less awed by it now. But my second thought was, yes, when people talk about the consciousness of it, rather than, maybe the question is do our brains do something similar that is therefore also like, is this just another kind of consciousness? I should say I've since kind of changed my mind on that.
Go on.
Because of the stuff. So I did a follow-up post to my original post, because I sort of went in search of an answer to that question, because the thing that really bothers me about LLMs, the thing that really the thing I find really annoying about the way that everyone is talking about modern AI is that not everyone, some people, some of the grifters, some of the billionaires, some of the people who have got, let's say, a dog in the fight.
Yep.
They are extrapolating to and making predictions that cannot possibly be true based on this technology. And the bit that fascinated me is not that people who've got a vested interest in this area would make something up. I mean, I've seen that happen for the last 20 years. I mean, I've had the big vendors in the office trying to sell me middleware and I don't know, whatever else is flavor of the year. They all lie. They all make stuff up. They all tell you tech does, will do things that it's not capable of. But this is quite different, because this is almost like a mass hallucination, because there are lots of people, intelligent people, all saying this. And that was when I came across some research, which actually goes back to the 90s, which is actually what humans do when they see, perceive, or hear language. And the thing, this idea of consciousness that's coming out of an LLM it's not coming out of the LLM. We're projecting it onto the words that are coming out of it, which has two really interesting implications. The first one is, let me just rewind a bit to just explain that first point a bit better. So what's her name? Patricia. You may need to put this in the notes, because I think her name's Patricia Cohl, Cohl. Have I got that right, or is it Cahl? She's a professor of language and development at Washington University in the States. She is. Did you find it?
No. Patricia. Yes. Speech and Hearing Sciences.
Yes, that's it.
Yeah. Is in the Bezos Family Foundation in Georgia for the early.
Yeah.
Yeah. Patricia.
Okay.
Kuhl.
Cool. Yeah. So I came across her research, which I believe goes back to the 90s. So Patricia Cohl is professor of her generic field is language development in human beings, and she's done
book, The Scientist in the Crib.
Yes.
Oh, okay. Sorry, go on.
She did some experiments watching babies learn language, but she was also able to use brain scanning technology in real time to see exactly what their brains were doing, and also study how the babies were interacting with the world around them in order to build the language centers in their brain.
Mm-hmm.
And the thing that she noticed was that the first thing that babies do is they tune for the language that they are, the cultural language that they're brought up in. So the reason that a Western speaker might find it difficult to understand, say, Mandarin, is because it's got tonal qualities that we would have been open to when we were a baby. But if you just grow up hearing English, you tune into English. It's also why children that grow up multilingual, if the earlier they learn a language, the better they will be able to learn it, because they won't tune out. So if you can speak French, German, English, and Mandarin, you probably got quite a broad. Your brain is tuned to quite a broad series of sounds. You take those sounds and you join them together into your brain to represent a word. So that's how words first appear. But the words on their own don't have any meaning. So if you were to take a baby and play at the words of Shakespeare with no other humans around, it would start to process the sounds, but there's no meaning to it, because the meaning comes from other human beings.
Right.
And the example that she used was if you have a baby who is watching TV, they're hearing sounds, trying to convert them into words, and then they're using the adult in the room as a kind of a meaning amplifier or meaning provider to associate those words with meaning, which makes sense to me, because a word is just a bunch of sounds. Like in all languages, there's similar meanings, but the sounds are different.
Yeah.
Back to those word vector things. If you take if you took a map of everything in English and mapped it over a map of everything in German, it turns out all the words actually stack up on top of each other. There's some like famous pictures of, you take Mandarin, you take German, you take English, you layer those multi-dimensional arrays over the top of each other. Turns out all the words that mean the same thing are near each other, because why wouldn't they be? The word for dog, a pet, cat, whatever, they live together in my brain in a certain area, and I associate certain sounds with them. But somebody who speaks Chinese would also have the same concept. They would just use a completely different set of sounds to communicate those things. So the concepts overlap each other. So the concepts are built in your brain, but they're built by interacting with typically your caregivers,
mm-hmm.
who will provide that meaning. So you can almost like take the language out, because our heads are, the language is like the words are like the gateway to the meaning. So when ChatGPT starts providing words to me, I'm the one providing the meaning, because years ago when I was, watching, Sesame Street or something, all of that meaning was then provided by people around me that then it lives in my head. So the idea of the consciousness being in the language doesn't actually make any sense, because consciousness, agency, intelligence, meaning, all of those things that we're trying to project onto these models, it's coming from us.
Yeah,
it's coming from us, and we can't help it, because we are like these language receptors. And that the reason we do it is, as Professor Cole talks about, is when we hear words, spoken words, our brains are spending a lot of time trying to understand the internal mind of the person that's saying them. The words are just a sort of a clumsy sounds that come out of your mouth. But what we're doing is we are processing those sounds, turning them into words, but most importantly, adding the meaning, because we're trying to understand the speaker's kind of contextual point of view. So the LLM is only trained on that bit in the middle. It's only trained on the stuff that comes out of my mouth that you can hear, or the stuff I write down that you can read. It's not trained on any of the meaning. It does have it's a representation of how those things relate to each other, but it is not in itself, it cannot be in and of itself embody any meaning or consciousness or agency or intelligence, because it's the leftover ashes of the fire. It's not the fire itself. It's the dead embers of something.
Does that mean we're all out of a job though?
Well, so that's a different thing, because if you if you understand that this is a vastly complicated, multi-dimensional array, for the want of a better word, that where all of these words live, and when you ask it a question, you basically trace a route through that multi-dimensional space to the point, and this is the really clever thing about the generative aspect of it as opposed to the say classification, is when I phrase a question in the model, the words that come next are the answer to the question. And that is a bit of a mind bender, but not so much when you think, well, no, of course it's not, because this thing is absolutely massive. It's a significant percentage of all human language.
Yeah.
So if you see it like that, if all it is it's like a Markov chain, but a very, 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 very clever one, and with loads of dimensions and the ability to like thread a question into an answer. And it's also probabilistic, as in it's not if you start saying something that doesn't make any sense, there's a very different response in our conversation. If you start hallucinating,
yes,
it would mean because there's something wrong. But these things hallucinate like by design. That's part of the design, because at some point, as Jan LeCun says, if you make these chains of words longer and longer and longer, the chances of it sort of wandering off common sense into hallucination, into some sort of ludicrous series of words, maybe grammatically correct, but ludicrous in the context of all the rest of the stuff, that probability increases the longer the context window. And you can't fix it. It's part of the design of the system. So is it going to take our jobs? Well, I can't see how it can, because when you see it for what it really is, what does it do that is exactly what a human does? I can see it supercharging someone's work. I can see it augmenting a developer's work. But ultimately, if it's not deterministic, and we'll always ask more and more of them. We'll always give it more code and ask it to fix this and ask it to fix that. We're going to start to reach the points where it won't do that, until it is trained on another set of data, which then raises a whole load of other interesting questions, which is there enough data that it's not been trained on left for it to do anything?
Mm-hmm.
And even if there was, can we afford it? Because the costs go up. I mean, it's plateauing. There hasn't been a huge leap forward in a model. Just take away the marketing. Just the actual, they've got better. There's no doubt they've got better. But if you double the investment, do you double the quality of the output? And all the science is pointing to no, and all the evidence so far is also pointing to no. So we're probably near the top of the sigmoid curve of innovation, in that we've sort of done the big innovation. And this doesn't mean that's the end. It just means it will be more expensive for less benefit. Probably. No one really knows, but probably. So how is it going to take our jobs? Well, it's not reliable. It's not reliable in the sense that Shopify, this is today, I saw this in the news this morning, is not going to let agentic software buy things on Shopify without a human validating it at the end. Now that's really interesting. Why would they do that? Well, clearly, because if agents start going and buy stuff and they have a few wobbles, who's going to take responsibility?
Who's doing the returns?
Yeah, and so then you think about things like lawyers, because an LLM can absorb all the law in the world, and you could navigate using your question and answer thing through the massive multi-dimensional matrix, and it will tell you about law. But it won't always tell you all of the law accurately all of the time. If you had a generic question about buying a house and you asked an LLM, it's probably quite useful. I mean, it will give you a sort of good grounding. I wouldn't go to a lawyer for a good grounding. I could, even before LLMs, I could have just used Google and found somebody who'd, some maybe a solicitor who likes blogging who would just write about that. So I've got no benefit. If I had a serious legal problem, I think I'd want a human, a lawyer. I'm fine with them using an LLM, but I'm paying for. Also, if I'm going to use an LLM, I'm not paying anyone, because I can't ask the legal question myself because I'm not a legal expert. So if I'm going to pay a lawyer to ask an LLM a question, I might as well just pay the lawyer to answer my question and say, dude, if you want to use an LLM to speed it up, awesome. But I'm not paying the LLM, I'm paying you.
Yeah, exactly.
So every example I've heard where LLMs are going to replace blah, I just keep going back to the same sort of few things, which is they're never going to be 100% reliable because it's part of the design of them not to be. I mean, I don't mean intentionally part of the design. The design means that they will never be 100% reliable. They've cost a fortune to get to this part, and it remains to be seen whether even the current vendors are ever going to make this money back, or the current investors, more specifically, are ever going to make that money back. Ed Zitron did a post a couple of days ago. Some in effect Claude users are costing 5,000-6,000% of their monthly fee.
Wow.
In token processing. So the question then is, okay, would they be prepared to pay? Would they be prepared for their bill to go up by 5,000%? Because that's if you want to make this thing pay its way, and that's paying the inference costs. That's not paying back the investor. So you've got to pay 5,000% of your current bill in order to keep using it. That keeps everyone happy. Now the investors want their money back, and they're going to probably want, let's say, twice the original investment back.
Yeah.
So now it's got to IPO, and enough share buyers are going to need to come along to believe in this thing that it's going to make money. So maybe you need to pay 6,000 or 7,000% in order to make this a viable business that could then IPO, that could then. I'm making those numbers up. It probably needs to be much higher. So you've got an accuracy problem. You've got a cost problem.
Yeah.
None of these things look surmountable. And yet at the same time, people are saying, well, it's going to take all of, other people's jobs. I'm just not seeing it. I'm not seeing it with the current technology. I'm not saying. So I'll tell you what I think is going to happen.
That was my next question.
Well, I would sort of like to be proven wrong, because I don't really want. I said the other day I was in an internet startup when the .com bubble burst, and there's so many things now. Back to the original thing about factors that led to AI winters. There were the same factors that led to the .com bubble bursting.
Yeah.
And I'm seeing them all the time. This sort of like unrestrained optimism. The sort of people talking about what the technology can do without really understanding the technology. They're all the proper ingredients for a bubble. Is if the AI bubble were to burst, and I think it'll only take something small. With the .com bubble, it was famously pets.com.
Yeah,
they got overvalued.
Mm-hmm.
The market went, well, they're never going to get this money back. Share price plummeted. Everyone else that was investing went, oh, I think I've invested in something that's doing the same thing. Right, I'm going to sell my shares. And then everybody started to sell. Then the investors took a bath. And then people like me couldn't get any work, because even though, was there anything wrong with .com technology? Because it seems to have worked out pretty well in the 20 years since. Like there was nothing wrong fundamentally with everything that we were building then, other than some businesses got massively overvalued. Investor hype went out of control. People started to predict things that weren't going to be true. The bubble burst, and all the really good technology underneath got sort of like, I mean, you could almost say there was a dot-com winter, I suppose, for what, about 5 years.
Yeah.
So I worry that we're about to go through something similar, and that's, I'm a massive fan of this kind of technology. I think in the sense that it can augment. I mean, think how powerful is it to have this sort of like data representation of language?
It's very powerful.
That you can navigate and get really. I mean, and I say this all the time, especially in things like software engineering, where the grammar of the language itself is constrained. So, I did have LLM when I was messing around with something a few weeks ago. Suddenly started writing Python in the middle when it should have been writing some React. But it did kind of make sense when I looked at what it was doing. It had gone off on a path of, it was a data sciencey thing, and so it just started writing Python. And now the thing is, because it was me, I'm looking at it and I'm like, why are you writing Python? Oh, yeah. Good spot. And then it went and corrected it. But the vibe coders, the people that are looking at this stuff and can't see what it's doing. I mean, that's a bit of an egregious example, changing language in the middle. But what if it writes code, as has been proven so many times, that's not very secure? Well, in a tool chain of software engineering where I've got a pipeline and tests and good engineers, then it's fine. I mean, it's just a bit of code that will get picked up and corrected, and then and no one will ever know. And it will speed up all of that work, and out the other end will come code developed faster.
Well, there's an interesting paper that's just been written about it not speeding engineers up and actually slowing them down, despite their perception.
I can see an argument in the way. I mean, I would say my very subjective n=1 personal experience with any of the sort of code generation, vibe coding things is it generally makes me faster. If I'm writing something that I know I can already write, I just can't be bothered because it's going to take me half an hour and I can just get it to do that. I've just saved half an hour and I've got it in 15 seconds.
Yeah.
And I'm now on to the next thing. I think it's going to have a profound effect on software engineering because it's going to make code, the value of code reduce, which have really interesting repercussions, I think, with legacy code, because as we get better at like putting a tool chain around it, then, rewriting a legacy system, I'm not saying it's going to make it trivial, but it's going to make rewriting legacy systems so much easier than it would otherwise be today. I would just add one other thing, because whenever anyone like me says, "Oh yeah, it's not going to take people's jobs. It's just going to, it's going to augment some jobs massively, and other jobs you might just summarize your meeting or something," people always say, "Well, you can't say it makes mistakes and it hallucinates because people make mistakes." But that's not a logical comparison.
No.
If you put an LLM in and it makes a mistake, it's made a mistake by design. Like it makes a mistake because it's saying this thing probably follows this thing. And sometimes it will be wrong. When a human being makes a mistake, it is a failure of the system, as in, I mean, humans don't go to work to make mistakes. And it's like a human making a mistake is an aberration in an otherwise supposedly slick system. And you can do something about it. You can train the person. You can move the person to a different job. You could replace the person. And then the system will go back to being its usual inefficient, terrible enterprise, dreadful culture. But a human system, an organization of human beings, yes, of course, there will always be mistakes. But it's not part of the design of the system that the human makes a mistake. The human makes a mistake for lots of other reasons, and those things generally can be dealt with as a single kind of event.
Yeah.
You don't worry about humans because someone put a bad LinkedIn post out.
No.
You know, you might worry about the individual. That's a different thing.
So, where does that leave us then? So, when all our jobs aren't going to be replaced by autonomous LLMs, but we're going to have to learn to live with them.
Yeah, I mean, so I've put 2 slightly inflammatory posts on LinkedIn in the last 2 weeks about AI. What was very interesting to me is that people, I got hardly any negative or pushback. I had a couple of people send some sort of generic views about it. But what was quite heartening is that people I know who are far better at the data science around this than I am agreed and were very positive about it, even though I sort of didn't. It was more of a generic piece about ranting about, you know, the craziness of overinflated valuations and people making proclamations about technology without understanding it. So I was very pleased about that. But what I tried to stick as far as possible to facts rather than my opinion, because I mean, obviously at the end of the day, everything is subjective, but I tried to stick to, you know, there's a price rise in Cursor. It was X, it's now Y. Here are people on Reddit talking about it. Mm-hmm. People say this because they definitely do. The LLM works like this because it definitely does. These aren't my opinions. These 2 things don't mix. Now, that's my opinion. These 2 things don't gel. And I've really tried hard not to jump in and speculate myself, because it'd be very easy for someone to, in 2 years' time, to go, yeah, you said this and this other thing happened.
Look what you said 2 years ago.
Yeah, but I think there's a reasonable sort of logical. I think you can plot the next, say, couple of years. And if I'm an LLM, I'm 90% sure that this is the next set of tokens that are going to come out in our history. So I think in the next 6 to 12 months, the finances of these organizations, the OpenAIs, Google's Gemini, and maybe not so much Facebook, because Mark Zuckerberg has got so much money that he can just sort of keep throwing more money at it. And if it doesn't work out, he can sort of quietly pretend it never was anything and no one's ever going to
go back to VR.
Yeah. But I think certainly the new kids on the block, let's say, because Google can survive, I think their financial situation is going to catch up with them, because investors might be attracted to shiny things, but they're not crazy. They're not. I mean, they wouldn't be investors if they were crazy. They will have to start looking for viable business models and exits for these businesses, and it will begin to dawn on them that that's not going to happen. And one of them is going to break first. This will be speeded up slightly because there's a huge public resentment to generally to AI, which I think is a bit some of it is a bit misguided. But I think if you're trying to make a business model for a product and no one wants it, I mean, you look how many people want to turn Gemini off in Google. Gemini is actually, it can be quite useful.
I'm loving Gemini.
Yeah, lots of people do. But if you go onto forums and look at people talking a bit, I'm talking about normal end users, not people like us who sort of go, oh, lovely tech, great. Normal end users, they don't want it. They want to be able to turn it off, and there has to be a reason why they're not making it easy to turn stuff off. The WhatsApp's got the little flipping circly. Yeah, so it's really annoying. And there's no way to just get rid of it, but people want to get rid of it. There's an overwhelming push by people to get rid of it. So you've got this clash. We need a business model. people don't like it. Then layer over the fact that the models are starting to plateau. So the only way to make them better is even more money. So now you've got an investor who's trying to make a business model and an exit, but the founder is saying, we need even more money than you've already given us. But the maths, all the papers are saying current models are reaching a dead end. And this is the bit that gets a bit sad, but there is some, like Jan LeCun's working on a sort of more like a sort of architecture for these, for models to sort of communicate, whatever. There's lots, I mean, not just his stuff, but there's lots of other interesting things where maybe investment would actually make a lot of sense. But I think what's going to happen is investors probably are going to break. One investor's going to break and go, and it'll be like the pets.com scenario. It takes one to break ranks. The others will think, I'm not going to make any money out of this. I need to cut my losses. There'll be a big collapse. It'll be all over the news. People who've been saying on LinkedIn for the last 3 years that AI is going to take over everything are going to quietly start trying to delete their posts or pretend that they always knew, or suddenly start talking about the risks of the models that they already had. But those models are there now. Like the money might be lost that was invested in them, but you wouldn't throw the model away.
No.
The model drastically drops in value, and then there's a bit that I hope, and then there's a bit that I fear. So what I hope is that research will continue, maybe smaller, tighter, domain-specific models, particularly like very targeted at coding and areas where areas where you can wrap this stuff, and some of the hallucinations and things don't matter as much. You can sort of like you can deal with it, and you can get productivity gains. So I would sort of hope that what happens is when it finally all comes crashing down, which it will, there's like somebody picks up those pieces and then tries to turn it into some useful products that support people rather than replace people. That would be the best outcome of this. Equally, investors don't get too shy of investing in. Maybe the words AI will become overloaded and it doesn't feel like it now. It feels weird to say this now, but maybe AI will become such a dirty word that people don't use it.
Yeah.
But machine learning as a collection of really interesting areas of study would get some investment, and people developing the next wave of models won't end up in an AI winter. They will get a certain amount of funding because there's loads of really cool stuff I think we can still build. Again, but it has to keep coming back to, it's for people, not to replace people, not to make billionaires richer. It's not a capitalist weapon. It is, I mean, I put this in my first LinkedIn post, and I know that you think the same. I got into technology because I thought I could build stuff that people would use.
Yeah.
And then get on and live their life. I didn't want to replace them or make their boss richer. I wanted them to be able to do stuff that's really boring really quickly, so that they can go off and do the interesting stuff. So that would be what I hope. What I fear, because unfortunately humans are too emotional. It was mostly men. Men are too emotional to run the world.
Controversial.
Yeah, that's another podcast. Is what I fear is that the bubble will burst, and then there'll be such a backlash from the investors and big financial institutions, because we might end up going into a global recession off the back of this, because some trillions are likely to go missing. So it could have a catastrophic effect on the world economy, and then it will all and then there'll be an overreaction, just like there was with the .com, where instead of picking up these models and doing something interesting, there'll just be this massive antibody reaction to technology. And we'll just have to sit and worry about getting clients for work and jobs and doing anything interesting for 3 or 4 years until that blows over, and then everyone forgets like they always do, and then we pick up and go and do something else. But it would be really nice to think that with so many bubbles bursting, that maybe, and I'm not, that's not totally wishful thinking, because with the .com bubble bursting, HTTP didn't go away. We didn't stop developing sites in JavaScript, unfortunately. But I think, there wasn't like this. It wasn't like pets.com disappeared and there was this residue that we could use. Pets.com just went and then was gone. But we will have a really interesting technology that is still there, that is still something you can access. I mean, we've not talked about the global warming implications of all these data centers at all. So I think that's not something to be just like brushed aside. But that's why I think, maybe some research into much smaller, more optimized, where you can actually make an argument that there is a general like net good.
Yeah.
I don't know if we've had a bubble where the bubbles burst and left a thing for us. A bit like an alien spacecraft has crashed, and a titanium hand is there in a museum. That's a Terminator reference. Yes, and we can sort of take that and do something with it. We could. It's like, so it's not complete wishful thinking.
Well, there is a lot that we have gone through today. There is a lot. I feel like we need a few more sessions to really pull all of these things out. But alas, we don't have time on this particular one.
No.
So, any thoughts in final closing? And you can mention Clippy if you want.
No, I don't need to mention Clippy. No, I think if everybody just calms down and sees this for what it is, it's unfortunate that some investors are going to lose some money, but actually, if everyone kept a cool head, it's not that bad. I'm worried that there's going to be a catastrophic overreaction, but there absolutely doesn't need to be. This is really interesting technology with a good fit in the right places. It's just not a systemic change it's not going to create the Terminators.
Well, thanks for that. That's going to help me sleep tonight. So thanks, Julian Browne, CTO at Modu Digital. Thank you so much for your time as ever. It's been an absolute pleasure.
Thank you very much.
This is Software Meets Business, a podcast sponsored by Head Channel.